So we've seen that an array is actually just a variable, but with a lot of internal pockets. All the indexes within your array are effectively mini storage spaces. Now you can create multi-dimensional arrays, 2D arrays and 3D arrays. Let's have a look at a 2D array and how to create one. Well, we declare one in pretty much the same way as a normal array, a normal one-dimensional array, by using the dim statement or the public statement, dim array 2D. And then in the open brackets, we need to provide two values. So if I were looking at creating a grid type situation, is what we're looking at here, I could go 3 by 3 as integer, and that will create me not just a single column of information called array 2D with 3 pockets in, but a 3 by 3 grid. So you can then reference any one of the storage locations, any one of the pigeonholes within that grid, simply by choosing the array name, so array 2D, and I may wish to get the cell right in the center. That will be 1, 1 equals 5600. So we assign values to a two-dimensional array by effectively giving it the x and the y coordinate of the pigeonhole. You can make these as big as you like, and we can do as we've done before and actually say we don't want the base to be 0, we want it to be 1. So we say 1 to 3 and 1 to 3. And at which point 1, 1 is now the top left-hand corner. If you think of this being an XY grid, where you're referencing each of the rectangles in that grid by its index number. So this little grid with 3 values and the index horizontally and 3 values indexed vertically will give us the option of 9 elements. Now you can even go that step further and create a 3D array that has 3 indexes, and the best way you can think of visualizing that is it's not a grid but a cube. So you've got an X, a Y and a Z coordinate. So we can declare the same way, dim array 3D, and then how many indexes are on each side of that cube. So if we were to have a 4, a 6 and an 8 as integer, you are creating a cube which has 4 values down the left, 6 values across the bottom, and then 8 values deep, which will give you a number of pigeonholes, a number of index locations that you can reference, add values to, read the value from. And in this particular case, because we've gone for 4 by 6 by 8, the number of indexes you actually allow are defined by 4 multiplied by 6 by 8. Now you can calculate that in your head, or you can ask the immediate window to do that for you. So question mark 4 by 6 by 8 equals 192. So our little array here, being created in a 3D format, will allow us to have 192 values within it. So instead of creating 192 variables, what effectively is one variable with lots of mini sublocations. Each of those sublocations can be referenced by its X, Y, and Z value. So I can place values in to any of those pigeonholes. So array 3D 3, 2, 4 equals 765. And I can pull values out, should I need to, into any other calculation or into a message box, whatever your pleasure might be, by the same process. Name of the array, open brackets, and then the 3 index references.